I know. It's been a really long day.
Imagine having a job too.
I know, I'm working on getting a job. I'm working on getting a job.
All right, guys.
I applied to Nicholas.
Everybody. Andrew.
Okay.
I want to point out real quick. I always point there. I'm sorry. There's a monitor there. I can see it. You guys look up here. Page 68. That might not be the same page number depending on the version of the book you got. You with me? So it should be chapter 1 review problems, right? So I just want to point out this worksheet we're doing. Those kind of problems will be kind of mixed into that first homework assignment. Y'all with me? So it comes from chapter 1, which is a review section, and you can look at each individual section if you want to. So you'll see some of that mixed in there. So I wanted to point that out and point out that the page number might be different in your book. Yes.
If they have the blue one, like mine, it's page 67 as well.
Yeah, the one I've got is the one that works for Calc 1, 2, and 3. So this is the mammoth. Look at that.
So this one is the one, it's the same as yours.
Probably. I mean, is it this thick? There you go. Okay.
You could do
There you go.
some-
So some of you guys might have gotten the
do
one that
workout
works for Calc 1 and 2 because you're like, I'm not going to Calc 3. So that makes sense. Don't get a book that goes to Calc 3. Makes sense. So I don't know if some of you guys have this skinnier book that goes Calc 1 and 2. You with me? And some of you guys have an e-book and you're like, that's skinny as hell, man. It exists only in the virtual world. So it has no dimensions. Yes?
The different versions of the 9th edition.
Yes, there's, like I just said, the main two are Calc 1 and 2 versus Calc 1, 2, and 3. And I can't remember if those two have different page numbers or not. Yeah. So that's always exciting. Is everybody with me so far? Guys, so I want to reiterate something. This worksheet we're working on now has some things that will show up eventually. They're not going to be like what the first part of this class is like. This is just the review stuff, right? And review for calculus involves a lot of mathematics. Have you guys done a lot of math to get here? Yes.
Yeah.
I love some of you guys are like, yeah. You guys have done a lot of math. Not math, So, of course, any review section is going to have a lot of stuff in it. But the important thing is, as we hit things, I'm going to review some of the stuff. And if there's something I don't review, you can just ask me a question about it. Not a big deal. What I'm trying to do with this is to highlight mistakes people make and why they're mistakes. And to remember stuff like the conjugates, right? Just to kind of dredge that up a bit. Are you guys all good? Okay. So again, I'm not going to grade this. This is not an indication of how well you're going to do whatever. Okay. So let's look at the rest of this here. Yeah. Let me get a nice clean sheet. So we're going to do this one now, which I think is probably a lot of people's favorite.
Are you sure about that?
I might be saying that as a sarcastic bent to my tone. So let me ask you an easier question. How would you factor this?
W squared on the side.
Yeah, you take a W squared out, right? And what do you do with the powers when you take something out with like basis? What do you do with the powers? When you take something out, why is this a W cubed? Because I subtracted, of course. In fact, you do it and you don't even think directly that's what you're doing. So when I start throwing negative powers in, you freak out a little bit because you don't think directly about what you just did. So what if I had this instead? No, get out. I want this one. So what's the idea behind this problem? Which power do I take out? The smaller one. That's generally what we do. So what's the smaller power here? Negative 5. So if I take W to the negative 5 out, what am I doing with it? What am I doing when I take something out? What operation am I
You're
applying?
subtracting.
I'm dividing, because when I put something in, I multiply, right? Now you guys are one step ahead of me. You're fine. I'm dividing that out, so what do I do with the powers? Subtract them. Is everybody with me?
Yes.
So the first one's easy because everything was positive, right? Now I'm dividing by w to the negative fifth. So I'm minusing a negative 5. So of course that means I'm adding 5. So what does this first thing become then? 7. How do you check yourself? You always want to know how to check yourself. When you bring this in, what do you get? You get freaking 2. Okay, so you can always check yourself as you're doing this, right? So what about here? What's w negative 5 divided by w negative 5? Holy shit. Okay. Notice the result has whole number positive powers. So in all the weirdness out here, and this guy is relatively not weird. So of course, for your problem, because I'm a math teacher, I amped it way the shit up, right? I cranked it to like 12. I looked at 11, I'm like, no. We're going to 12. But the same idea, which power, now real quick, I'm sorry, let's do this. How you look at any problem like this? 2 terms. You guys agree with me there's 2 terms?
Yes.
Good. What number comes out? Yeah, and an m. So we do it step by step. I can take a 2 out. I can take an m out. How many m minus 3 is going to take out? Good, the smaller power. Why? Because we always take out the smaller power. We know this. We just don't see this kind of thing too often, and you are going to see this often enough here. So of course, negative 4/3. When I take something out, when I undistribute it, I'm going to divide it because distribution is multiplication. When I divide stuff with powers, I subtract the powers. I just took a negative power out, correct?
Mm-hmm.
So minus a negative is plus. So I'm actually going to add 4/3. So read with me.
5.
So what's left in the first dude? 2m. And then 4/3 plus negative 4/3 is 0. So I got no m minus 3's left. Or you could just think I took them all out. So there's none of those left. Plus 6m divided by 2m. 3. M's gone, yes?
Yes.
And then how many m minus 3's do I have left? Good! Negative 1/3 plus 4/3 is 3/3 is 1. Alright, we're not done with that, but let you just gaze upon that weird shit.
Or not.
Come back. Please. Thank you. I know technology rules me, so whatever you need. My technological overlord. You guys with me so far? I need you to notice something. This specific problem has a very interesting thing about math. The process does not give a shit what's in there. Well, how do I factor something with like bases? I take out the smallest power. That's the process. We care that it's freaking negative freaking fractions, Jeff. What the shit? But the process says take out the smaller power. Right, you with me? Process doesn't change. What we do for individual problems changes because in here I got negative fractions. Oh shit. But I'm still going to take the smaller one out. When I divide it out, I subtract it. Are you guys semi with me? So this looks worse, but it's the same damn problem as w squared plus w to the fifth. It's exactly the same problem. Take out the smaller power and subtract it. We do exactly the same thing. Why am I not quite done? One little thing. No, I can't do shit with that. It's too bad for me. But I appreciate your concern. We don't like it, but too bad. We're stuck with it. Yes. Yeah, inside I can do some stuff, right? So I get 2m, this freaky negative 4/3 of an m minus 3, and then I get 2m plus 3m is 5m minus 9. Is that all right? So I don't have to write as much? You can distribute the 3m and get your like terms together. Is that okay? 3m minus 9, so 5m minus 9.
I missed something kind of. What did you do with the square there, the 4m squared?
I did nothing with it. So 4 divided by 2 is 2. M squared, take 1 away, I have 1 left. I took 2m out. So each term lost an m, yes?
Oh,
This is 1m because it had 2. This is no m's because it only had 1 and we took it. Poor little dude. Yes? You totally did, but I'm not going to write it. We just don't write 1 power. Yeah, cool. I like it. We don't write a 1 in front. We don't write 1 power. We don't write 1 underneath. We don't write a first root. It's a billion little understood ones. Yes?
So did you like back to the first part or?
So what I did, I looked at the numbers and I saw a 2 could come out. I looked at the letters and I saw I could take one M out. And then I said, how many M minus 3's can I take out? Negative 4/3, the smaller power, right? And then I just have to deal with the aftermath. When I take something out, I divide it out. When I divide like bases, I subtract powers. So when you take a negative power out, you end up adding that power because minus and negative is plus. You guys all with me? A little bit, okay. And again, this is a lot. I understand that. But I wanted to kind of come back. And you guys don't really do this kind of problem very often. It's not your fault. Just we didn't give you this kind of problem enough. But we're going to see this kind of problem often enough. Okay.
Isn't that where we start doing derivatives?
Derivatives, totally. Yes.
Oh, yay.
Some of you guys have probably heard that word, yes?
Yeah.
Some of you guys, you're like, I took the calc. What are you talking about? I'm here again, so I know all this shit, Jeff. But I just hopefully this time it's going to go better. But some of you guys have never taken calc before, but you might have heard the word derivative, maybe. Has anybody never heard the word derivative in terms of math? Anybody? Okay, I like it. There's a few people. Okay, so good. You're going to learn. We're going to get there. Okay. Now, what I believe might be some people's favorite part here. Again, sarcastic. You got to know your trig. And you have to know your trig identities. It's not as important, but it still is in 180. How many of you guys are going to plan on taking 280? Calc 2. So let me just tell you this. In the first chapter you work in, there are like 3 or 4 sections devoted to nothing but methods that involve trigonometry. Just to let you know, not to freak you out, but if your trig is a little weak, that's the very first damn thing you want to focus on if you're about to take Calc 2. Holy shit. So what I try to do in Calc 1 is I try to infuse trig. I could teach Calc 1 with very little trig, but then my Calc 2 students are getting screwed over. So I make sure to infuse. So if you're not taking Calc 2, you're going to get trig out of here. You're going to get some trig, too bad. I'm trying to make sure my Calc 2 students, you keep that stuff alive. Yeah?
I have a question. If you have a student taking Calc 2, you recommend them take Physics 101 as well at the same time?
You can. It's concurrent. Physics 101 or 141?
I think it's 141 or whatever.
Yeah.
I forgot what the name of it is. But
There's a
can't
physics
I
that
can't
allows you to
that
either
one
take the
until
calc before or you can take it concurrently.
Yeah, because there's a class that's in physics that I cannot take until I pass this class.
Oh, I see. Okay. I would recommend that you not take it concurrently. I would recommend you finish your calc before you take it. But they do allow you to take it concurrently in case you need to fit it.
Yeah.
You with me? But I would, as a student, I would feel better having a firmer handle on it when I entered physics. Yes?
Every counselor I've ever spoken to says Calc 2 and Physics 1 is the way to go.
Oh yeah, because Physics 1 requires Calc 1, I'm pretty sure. Yeah, so you will have finished Calc 1, so you're ready for Physics 1. Yeah, okay, great. Sorry, for anybody who doesn't need physics, I'm sorry. So, on this very first problem, what is trig? What is sine and cosine? What are they based on? Ratios of sides of right triangles. That's all they're based on. How much do we do with trig? A lot. Thank you. So we do a lot with it. But the funny thing is, every damn thing you've ever done with trig, just think back, they're all based on ratios of sides of right triangles. That's all they freaking are. But that's powerful. Holy shit, that's unnaturally powerful. So the very first thing up there, how many people have heard of SOHCAHTOA? All right, let me say something. I'm not gonna make you not use SOHCAHTOA, but I need you to understand. It helps you this much. If you understand sine goes like y, cosine goes like x, that takes you through everything. So what the hell do I mean by that? Does anyone know what this cosine of 0 degrees is? Y. Because cosine likes x, 0 degrees is all x, therefore it's as big as it can be, 1. So cosine of 90 degrees, is there any x piece to this? It's all y. So of course cosine of 90 degrees is 0, because cosine likes x. So as this grows, as my angle grows, the x shadow gets smaller and smaller, correct? Until here, there's no shadow. So of course it's 0. Sine goes the other way. Sine is the y piece. So sine of 0 is 0. It's no y piece yet. But the minute I grow a little bit, now there's a little bit of a sine of a y piece. And as I move up, the y piece gets bigger and bigger and bigger until it's nothing but freaking y. Are you guys at all with me? Yeah, like it. So, have you guys, let me see. Have you guys ever seen this before? So look at sine. Sine of 0 degrees is 0. Zoom out, Jeff. Does anyone know what sine of 30 degrees is? So it grows a little bit. Do you see the y piece? There's a y piece now, and it's 1/2. As long as this is the unit circle, that's 1, yes? Okay, I lie, okay? What's sine of 45? So let's take a step back. That's rad 2 over 2. Do you all agree the square root of 1 is still 1? So can't I say that's the square root of 1 over 2? It's kind of silly. It's like me saying I live about square root of 17 miles away. It's like, what the shit's wrong with you? But I can say the square root of 1 over 2. Isn't the square root of 0 still 0?
Yeah.
Is the square root of 0 divided by 2 still 0? Okay, now this is dumb. This is not the reason why or any of that. It's just a coincidence. Do you see the pattern? Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2. So what's sine of 60?
3 over
Square root of 3 over 2. Now keep it going. Good Lord, Jeff, if you could just, you're a math teacher, if you could just write numbers, it'd be amazing. Sine of 90, just following the pattern, it would be
That would be root
root 4 over 2. What's the square root of 4? 2. What's 2 divided 2? 1. Okay. So I mean, again, I have no idea if you guys have ever seen that. It's just a little side note. Doesn't have anything to do with anything. It's just a neat little thing. Cosine does the exact opposite. Because again, as I lift up, my x piece of the triangle gets smaller and smaller and smaller. So it does exactly the same. So 45 degrees, sine and cosine are equal. So what's tangent of 45 degrees?
1.
Because tangent is defined to be, no, tangent is defined to be what over what?
Sine
Sine over
cosine.
cosine. I like it. So where they're equal, of course it'll be 1. Okay. So coming back to this dude, you gotta know your radians. Man.
Brad, 3 over 2.
Sorry, I like that. Yes, so cosine of pi over 3. What is this in degrees? And why is that easy? Because pi is 180 degrees. I love it. Cosine likes x. 60 degrees is far away from the x-axis, so cosine should be small there. So what is cosine of pi over 3?
Oh,
A half. There we go. See, that's the way I think about it. I don't have this shit memorized. I literally think that, what I just said. Cosine likes x, that's far away, that should be smaller, it's 1/2. You guys that all with me? Now, listen, if you haven't memorized, great, do it. I don't want to memorize shit. What should I do for myself here?
Well, you gotta go clockwise.
Yeah, so if I go backwards, how far have I gone so far? Negative 180. So how far do I have to go past that? So all a reference angle is how much I overshoot or undershoot the
Oh, I made
x-axis.
a boo-boo.
You're fine. You guys with me? All a reference angle is how much you over or undershoot the x-axis. That puts me back into the first quadrant. That's why you only have to memorize first quadrant values. Tangent in that, what quadrant are we in? Second. What's tangent going to be in that? Positive or negative? Negative, because x and y have different. X is negative, y is positive, so tangent is the ratio of those, so of course it's going to be negative. Is everybody with me? I love it when I say that question, I get people looking at me. Yeah, I'm sorry.
Negative root 2.
Reference angle, how far away from the x-axis I am. Whatever quadrant I end up with tells me what SIGN is going to be, sine. So I know the answer is going to be negative.
Negative root 2.
I know this is tangent 45. So it's negative 1. Kick ass. Now everybody's real favorite. What the hell is this mean here? Inverse, not reciprocal, correct? It's not secant. It's the inverse function. What do I normally plug into a trig function? What kind of thing physically?
Like an angle?
An angle, right? You shove an angle into a trig function, correct? You guys kinda with me?
They're gonna stick a ratio in there instead.
Good. So what's gonna come out of an inverse trig? If I
An
put
angle.
an
An
angle
angle.
into a trig, what comes out of an inverse trig? An angle, right? Because they undo each other, correct? So the output of an inverse trig is an angle. I know a lot of shit about the angle that that's talking about. I know that this is the angle such that the cosine is 2 over x. Do you guys see that?
Yeah.
That is the angle that would make the cosine 2 over x, because like Mike just said, is the input for an inverse trig is the ratio it would be. They undo each other. What's the output to a trig? A ratio of sides of a triangle. So what's the input to a freaking inverse trig? The ratio of 2 sides of a triangle. What 2 sides are we talking about? Because it's freaking cosine. Where's 2 go?
Talking about the adjacent. and
Where's
the-
2 go? You got SOHCAHTOA language happening. 2 is this the x side, because cosine goes like x. And where's x? Hypotenuse, kick ass. Now this question is easier, because now I just want to know what the cosecant of that angle is. And what's cosecant?
It's
Whatever sine.
Sine over.
What am I missing to figure out the sine? If I knew the sine of the damn thing, I could just reciprocate it. What am I missing to know the sine? The y side. Because I want to. I'm sorry. Can you figure out the y side?
It's the complement of the cosine, isn't it?
Say it again.
Like the sine
Oh,
is the complement of the cosine.
yes. I see where you're going with that, but not, doesn't really help me out here.
Okay.
So how do I figure out this side? What do I use, of course? Yeah, old Greek dude.
Pythagoras.
So this will be, just to cut to the chase, this will be x squared minus 2 squared. Is that cool? Are you guys alright? No, if I call this a, this will be a squared plus 2 squared equals x squared.
Mm-hmm.
Yeah.
So x squared minus 4, is that alright? Oops, sorry, I'm so zoomed in. Is that alright? So then what's the cosecant of this angle? I'm sorry, of this triangle?
X over X over.
Yeah, it'll be x over a, and what's a?
X.
I wouldn't make you do that on this. This is ugly enough. But you're right, Brandon. We should rationalize it, but that's plenty for that problem. Does anyone remember that? If I see an inverse trig, I can always draw the representative triangle the angle lives in. Because the inverse trig tells me the ratio of the sides. If I would have put inverse cosine of 3, I could always just put 3 over 1, and then I know what side is 3 and what side is 1. You guys know what that. Now I just made a faux pas there. What's wrong with me saying the inverse cosine of 3? No, it's 3 over 1. The output of a cosine cannot be bigger than 1. Yes.
You might have just said it, but I was thinking, could you also say, and I might be repeating what you're saying, but like cosine, inverse cosine 2 over x is like an angle, kind of imagine it as it's like maybe cosecant of 45 degrees is still the same thing, kind of thing, right?
Yeah, this is some angle.
Yeah.
We don't know what it is, but it's exactly the same as me saying what's the cosecant of 45 degrees. It's just it's not 45 degrees. It's whatever the hell weird thing it is.
Yeah.
But it is an angle.
Yeah.
Okay.
That's what I just thought of.
Okay. All right. So, what I want to do for the rest of the time, I am going to let us out a little early, just so you don't totally hate me. Also, because I want to go home early. It's going to be the future. I want to get a little bit into the first part of real calculus. And what I want to do, I'm going to do it a little bit out of order from the book, because I really want it to make sense as to why we're about to study what we're about to study. I said calculus is looking at the slope of functions that aren't linear, correct? That is the first half of calculus, is what's the slope of something that isn't linear? That means the slope is constantly changing, yes? So can the slope be a number then? It's gotta be able to constantly change, correct? You guys with me? So therefore, the slope itself needs to be a function. So that whatever point I'm interested in, I can plug it into the function and I can figure out what the slope is there. Maybe. So, what I need to do is take the way that we figured out slope in algebra and beef it up a little bit. The funny thing about the entire first part of calculus is, it's just algebra slope beefed up. Can somebody tell me any damn thing you remember about calculating the slope from algebra? Chickens the exit. In words, it's right over run, right? But the mathematical formula, how you compute it is y2 minus y1 over 2. I love it. Kick ass. All right, so let's do this. So in algebra, I'm given 2 points. This comma got a little overexcited. He apologizes. So the slope between these 2 points. Okay. So the first level of beefing this up a little bit is this. Is everybody with me on this? Does this sound familiar? You guys remember this business, right? Okay. So if it's a straight line, it doesn't matter what 2 points you pick because the slope never changes. Right? Slope. Slope never changes. Okay. I'm around purple. So what I want to do now is say, what if I'm given a function and I want to know the slope between two x values? Let's just say x1 and x2. So I'm given a function and I want to know the slope between x1 and x2. You guys all with me? What do I need to calculate to be able to figure out the slope?
Need to know what y1 or y2.
Yeah, how do I get y2? Beautiful, okay. So to get y2, I would have to plug x2 in, and to get y1, I'd plug x1 in. Yeah, is everybody with me? So it's just one step removed. F of x takes the place of y. So now I'm just saying, what if I just gave us some function? So this function could be anything. Wah! And I just want to know what's the slope between two of the points. What's the straight slope between two of the points? Yes? Pretend like that's. Oh Jesus! What is the straight slope between those 2 points? So again, I need the outputs because that's what I put on top, and I need the inputs, and the inputs were given to me. So this is just one step away from y2 minus y1. It'll be now the slope officially is f of x2 minus f of x1 divided by x2 minus x1. Is that cool?
Yeah.
Isn't that the thing for the tangent line?
You're getting a little, yeah. Eventually this is gonna, yeah. Okay. Not too amazing, yes? All right. So let's get free.
Okay.
Calculus says, oh, that's nice. But I want to know the slope right at this point. I want to know the slope at that point exactly. Do you guys all agree with me? What's the slope here? Can anybody tell me anything about the slope here?
It's increasing.
It's
So what's true about it?
positive.
Positive. What happens about right here?
It's becoming 0.
It's flat, so it's 0. Do you all agree with me that at every single input there is a slope? Do you all agree with me? The way I've drawn this, that slope is consistently changing. Not by much. It's not changed by much until it gets to about here. Then it's changing quite a bit. You guys kind of with me? And then it gets to 0, and then what happens to it? It becomes negative. So the slope at that point is relatively, not too big, but it's negative for sure. You guys kind of with me?
Precipitous.
What's wrong? Why does algebra freak out about this question? How many points does algebra need? To be able to, it needs freaking 2 points. So what's algebra going to say if it could talk? Well, here's algebra right there. Little dude. And I say, algebra, what's the slope of the point? What's he going to say? I don't know. So I need 2 points to be able to do this algebraically. In fact, I don't know any other way to do it without 2 points. I need 2 points. But calculus says, no. I want to know exactly what the shit that is. You guys kind of with me? moment. So for example, if you are twirling something around your head and you let go, it will go at the same slope as the last direction it was pointing right when you let it go. So isn't it important for us to know what that direction is? Say again. I'm sorry. Are you guys at all with me? So I need to know what's the rate of change of that particle right at that point. Okay, so the way we do this, so let me call this x1. You know, like do whatever you want to, man. So that's f of x1. So the way we do this is we go a little bit over. I add like h to it, just a little. H is just as little, like h is, right? It's just a little bit of a movement. Are you guys with me? H is very tiny normally. Could algebra figure out the slope between those 2 points?
Yeah.
Yes. Can you guys set up what that slope would look like without saying a word? Nothing major. What's the slope? y2 minus y1 over x2 minus x1. You all have exactly what the shit you need. Can you set up what that slope would look like? Trust you. What are the inputs? What are the 2 inputs? x1 and x1 plus h. Right? So isn't the slope y2 minus y1 over x2 minus x1? Yes? Okay. What's y1? F of x1. And x1 is x1. That's amazing. That is a groundbreaking statement. What is y2? F of x1 plus h, yes? And what's x2? You can do it. Somebody just, x1 plus h. What happens on the bottom there? Yeah. Oh, my writing sucks so bad. Have you guys picked up on that yet? Sorry. If you wanted a teacher that you could read the writing, you've chosen poorly. That looks weird, but it kind of makes sense because h is how far apart the x's are. Isn't that what x2 minus x1 is? It's how far apart the x's are? Just the way I've set it up, I happen to know they're h apart. So of course the bottom's h. That's how far apart they are, right? Maybe. And you're all like, all right, Jeff, you've made it look worse, thanks. So this is still algebra. But have we answered the question yet? Is the slope between those 2 points the slope that the original problem wanted? Isn't that going to be not the same as the slope right here? I like it. So how do I improve this? How do I make my estimation better?
Could we find another point at x1 minus h?
Oh, I see. It might work with some functions, but x1 minus h for this one will be over here, so I think you're thinking about like averaging them out or something. Yeah, okay. That's not a bad idea. I like it. Does someone, based on my picture, how can I make this better?
Make h smaller.
Make h smaller. Effectively get this point to be closer, yes? Do you guys agree that would make my estimation better? If I made h too big, and I was freaking over here, what would it look like the slope is? 0 is obviously wrong. So I don't want h to be too big. So what makes it better if I make h small? What would make it perfect? What would make it perfect if I make h? But why is that a problem? If I make h 0, how many points do I have? 1. Do you guys see that? Then x1 and x1 plus h would both be x1 and have 1 point again. That's the whole problem. Is everybody kind of with me? I want to know the slope at that point, and we know there is a slope at that point. We know it, because you told me at the very top it's 0. So every single point must have a slope. You guys with me? So there must be a way to figure out the damn slope, because the slope formula is pretty straightforward. Well, there's got to be a way to do this. So what we want to do now is we want to construct a mathematical process. Oh shit, that's a phrase. We want to construct a math process that allows me to make h really small, but never let it be 0. Do you all agree that if I make h really, really small, That improves my approximation. What if I cut that in half? Isn't that better now? What if I cut that in 1/100000th? Isn't that better now? What if I cut that in 1/10000000th? What if I cut that in 1/100000th? So I need a process that allows me to do that in a better way than just going insane and doing it forever, right? So here's the idea with this process. Okay. Let me just tell you what this is called. And this is something you should have maybe seen in pre-calculus, depending on your teacher. I can't remember what I did with you guys now, to be honest. I taught pre-calculus to some of you guys. Do you guys remember in pre-calculus? No, I don't want to do that. So this is called limits. And I'm sorry if some of you guys grown. I'm sorry. If you've had bad experience with limits before.
Like an asymptote.
Yeah, asymptotes are types of limits. So in pre-calculus, do you guys remember? Let me just do this real quick. Does anyone remember what the horizontal asymptote would be for this? Kick ass. Horizontal asymptote is 1/3. Why? Because they're the same degree. Does this sound vaguely familiar?
Leading coefficients of the highest number.
Kick ass. So when they're the same degree, it's the leading coefficient ratio, right? But what's the idea of the horizontal asymptote? When does the horizontal asymptote actually kick in? When x gets really big. So when x gets really, really big, how important is +5? When x is 18 trillion to the 18 trillionth power, how important is +5? No.
Not very much.
How important is -7? No. So none of this shit means anything. So of course, when x gets really big, this reduces to 1/3. If you put 18 trillion into this in your calculator, it would give you 1/3, because that's within its tolerance. It's like, it's the best I can do. So here's what that looks like mathematically. If I let x go to infinity, has anyone ever seen this kind of representation? Now, here's the more important part. What is the limit as x goes to infinity of this function? It's 1/3. Real quick, can I ever get to infinity?
No.
Is the output of this ever equal to 1/3? No, never. Never is it 1/3. So what does this freaking statement mean? The closer I get to infinity, the larger my input gets. I can't get close to infinity because infinity is infinitely far away from me. But as my inputs get really big, my outputs must get close to 1/3. You guys kind of with me? How does this limit idea help us with the calculus thing we're trying to do? What did we say we want to let h go to but never get to? 0. If I can make h go to 0 but never get there, don't I always have 2 points? I'm always able to calculate slope. But if I let it get really close to 0, I'm going to figure out what does it look like the slope is there. So it's a way around. Now listen, I want to make sure that you understand this. This is one application of limits. This is normally the first place you guys learn limits, but limits are not only used for this. This is one application. You with me? So the limits don't exist just for this. I'm making it sound like they do, but it's not the point. For us though, I want limits to make sense. I have to have 2 points, or else the whole process goes to shit. Yes? I need y2 minus y1.
Is there a reason why you would choose positive versus like one space?
Yeah, the h could be negative. We just let it go to 0. For the convenience, we normally think of it as positive, just so we can kind of think of it the same way. But it wouldn't matter if it was minus h. It would be the exact same answer. In fact, we'll talk about limits themselves, and they can go from both directions. Yeah. Okay. You guys kind of with me? Okay. So if I let h get really as close to 0 as I can, I still have 2 points, but the answer will effectively be the answer. Okay, maybe. So let's try one concrete problem out. Yeah, good. I don't want to lie to you. I said we're going to leave early. So let's say I'm given the function x squared. And I want to know the slope at 1, 1. So what I wanna do is I still have to use this fundamental idea. And I'm writing this a lot, and we're not gonna write this a lot. I just wanna go back to this, because this is what everything's built on. So what am I gonna put? I wanna know at 1, what's the slope? So where's my other point gonna be? Where's my other input gonna be? 1 plus h, 11. Yes? Okay. So of course I had to put a weight of shit over there. Alright, just pretend like it's there. I wanna have a nice visual. Okay. So there's my other output, f of 1 plus h. So this slope is gonna be the limit as h goes to 0. So that's the way we get around. I want 1 point, but I must always have 2 points. So what's the way around that? I get as close to 0 as physically possible without ever getting to 0, so I always have 2 points. What's y2? Good, f of 1 plus h. What's y1? 1. Kick ass, we know that from the beginning, yes? What's x2? 1 plus h. And what's x1? 1. Okay. I'm gonna stop for a minute. I need you guys to see. This is the output at x2, so that's y2. This is the output at x1, that's y1. So it's still y2 minus y1 over x2 minus x1. That's all it ever is. But what's the bottom become now? H. So what is the problem with just plugging a 0 in for h? I'm divided by 0. Now to be honest, it's even worse than that. We'll see this in a minute. Can you guys take a minute? What's f again? What's f of x? No. What is f of x? X squared. Can you take a minute, figure out what f of 1 plus h is? And by the way, it's not x squared plus h. No, shit, no. I want to know what f of 1 plus 3, real quick. F of x is x squared, correct? What's f of 3? Holy shit. What's f of a? A squared. So what's f of 1 plus h? 1 plus h squared. How do you do that? Do it. Oh, wait. Figure out what f of 1 plus h by itself is. This is called a construction approach to doing a problem. The problem needs to know what f of 1 plus h is. Let me focus on that shit and then throw it in. So you're not doing too much at once, right? So focus on f of 1 plus h. Be careful, it's not 1 plus h squared.
1 plus 2h plus h.
Good. 1 plus 2h plus h squared, right? Of course you get a middle term, right? You write it twice, okay, 11. So now we can throw that business in here. So f of 1 plus h is 1 plus 2h plus h squared. And I have a minus 1 here, yes?
All h's. It'll be h plus 2.
Eventually, I love it. The ones here cancel, yes? And then what happens with this? So just like my man here said, they each lose an h. So I get 2 plus h. Now can I let h go to 0? And what do I get? 2. So notice something. I want you to notice something. And again, I want you to realize a couple things. I'm sort of doing things out of order from the book because I want you to be motivated as to why we're going to study limits. We're going to spend a decent chunk of time talking about frickin' limits. A lot of the time, they're not going to be connected to the calculus. It's just going to be limits by themselves. So I really want you to understand, this is the calculus. Now we need to really understand limits because they're important. They're freaking the whole idea. So we're going to focus on limits, and we're going to eventually bring this back. And we're going to say, okay, here's how it applies to the calculus stuff. And I want you to see why we're spending so much time on limits. It's the whole thing, yeah.
And all of that's literally just finding the limit of 0.
as h goes to 0, which physically means move this one point really close to the other point. So as I do that, my approximation gets better and better and better and better and better, and I'm basically making it as close to 0 as possible, the distance. Let me stop for a minute. Why does this make sense, by the way? From the picture here, what's true about the slope here? Positive, so we got a positive 2. Yes, that's about all we can say at the moment. There's no way you could have known it was going to be 2 ahead of time, but it is 2. All right. What do you think the slope would be at 0, 0? Freaking 0. What do you think it would be at negative 1, 1? Negative 2, because it's symmetric. So of course, if there's a slope of 2 here, there must be a slope of negative 2 there. Does that make sense? Okay. Okay. I like it. Also notice this. You guys told me that I can't plug a 0 in because I'm dividing by 0, correct? Mm-hmm. But what's the top if I plug a 0 in for h? 0. So what's 0 divided by almost anything? 0 divided by 7 is 0, correct? And what's anything divided by 0? Undefined or infinite. So somehow 0 divided by 0 is both 0 and infinity at the same time. Oh shit. Sorry. As I suddenly lose all my button. You guys kind of with me? So what I want to have happen on these kind of problems is, do you notice how the whole problem canceled? If I kill an h, the problem's gone. Now I can plug a 0 in and get the answer. All right. Last thing, now I'll check. Ha! Wyatt got all excited. Just to show you what limits by themselves do. This is not connected to a slope or anything necessarily. Why can I not just plug a 3 in? Yeah, now real quick, if just the bottom was 0, the answer could maybe be positive infinity or negative infinity. So I could actually get an answer. I want you to realize what's worse here is it is 0 over 0, correct? We call that form indeterminate, which means I cannot determine the answer yet. That's why I love that word. It is 0 over 0 or infinity over infinity. They're both called indeterminate. What that means is, I gotta figure, can I do some shit to this? Can I do something? And of course, what do you guys see that you're screaming for to be done? Factor the top, yes? How do you factor the top? And of course, what happens? Right here, do you notice the problem cancels? The whole reason it was 0 over 0 cancels. Now, real quick, I want to make this really clear. Is x ever equal to 3? That's the whole idea with limits, is it's the limit as x approaches 3. It never gets to 3. If x was equal to 3, I could not do this. The one input these do not cancel for is 3. Because 0 divided by 0 is not 1. Well, what the shit it is, right? But is x ever equal to 3? No. And any other freaking number I put in here, these cancel. So that's the power of the limit. It doesn't let you get to that weird place. The thing I like to say is, there's an old movie called The Blob.
Oh my gosh, the blob.
I love it. And in the beginning of the movie, this meteorite crashes, a little thing opens, and this little blob comes out. There's this guy who's like, what's that? And he actually touches the damn thing, and it grabs into his arm, and eats him, and all of a sudden the movie happens, right? So if you see something that's weird, are you going to actually touch the damn thing? No. What are you going to do, though? If you're curious, you're going to be, you're dead. You're going to get close to it without ever getting there. So that's what a limit does. Weird shit happens at 3. So we have developed a mathematical process that is the equivalent of, what is that thing? Which is, don't get to 3, get really close. So what do I get now? Now that the problem is gone, I get 6. Okay, so if I graph this, it would have an open circle at 3, 6. Okay, maybe that sounds familiar, I don't know. All right, guys, listen, I'm sorry. I wanted to let you out a little early. This is very little early, but too bad. So let me know if you have any questions or something, or if you need something, let me know. Or you can